A very happy and a warm good morning to you all children. Now we are going to continue with the last week's lesson, that is metals and non-metals. We have seen about the different properties of metals and non-metals in the last week class. Now we will extend the study of this in understanding the reactivity series and how are they being listed and what is the easy way to remember the elements in the order of their decreasing reactivity. Then we will see about the formation of ionic bond, the reaction between a metal and a non-metal gives rise to ionic bond. And what are the properties of ionic compounds? That also we are going to see in today's class. And we will see about what is a mineral, what is a ore, and how the metals are extracted from its ore. So the process of extraction of metals, which are in the top, middle, and lower reactivity series, what are the steps involved in the extraction of the metals? So all this we are going to see in today's lesson. So it is a very important lesson or topic which you have to listen very carefully, and please listen and get understand. After listening to all the slides, just refer your textbook and go through your textbook. You will understand more and more, and you have to highlight the important lines from the textbook by using a highlighter. Okay children, we will now go into the lessons. Children, what you see in this slide is the reactivity series of metals. This reactivity series we had started with the last week. What is a reactivity series? The reactivity series is a list of metals arranged in the order of their decreasing activities. On the basis of their reactive tendency to lose electrons and their reactive nature, metals are arranged in series. This series is called activity series or reactivity series of metals. The metals that are placed above hydrogen are called most reactive metals, and the metals that are placed below hydrogen are called least reactive metals. Now let us list the metals from top to down. It starts with potassium, then sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Here children, how to remember this series? For each metal, I have given you the clue word by the side of it. So remember this sentence: please stop calling me a careless zebra. Instead, try learning how copper saves gold. Again, please stop calling me a careless zebra. Instead, try learning how copper saves gold. Though this is a meaningless sentence, but it helps us a lot in knowing or remembering the reactivity series from the most reactive metal to the least reactive metal. Now let us see the reaction between metals and non-metals. The reaction between metals and non-metal makes us to get ionic bond. Let us see very deeply into this, and this is a very important question as far as the CBSE board is concerned. Each element wants to have a completely filled valence shell. That means it wants to have either 2 or 8 electrons in their outermost shell. Metals have a tendency to lose electrons and nonmetals have a tendency to gain electrons. When metals and nonmetals react with each other, then both of them tries to achieve completely filled outermost shell by transferring of electrons. Example, electronic configuration of sodium is 2, 8, 1, and in order to complete its octant, that is 8 electrons in the outermost shell, it is easier for sodium to lose 1 electron from the last shell rather than accepting 7 electrons in it. Thus, it has a tendency to lose 1 electron to have completely filled valence shell. Similarly, if we see the electronic configuration of chlorine, it will be 2, 8, 7, which is a nonmetal. We found that it is easier for the chlorine to gain 1 electron in the last shell rather than losing 7 electrons from it. So, it has a tendency to gain electrons to have completely filled orbits. If sodium and chlorine react with each other, then electron is lost by sodium and electron is gained by chlorine. So, Na plus and Cl minus ions being oppositely charged attract each other and held by strong electrostatic force of attraction to exist as NaCl. Thus, an ionic bond is formed. Let us further see about ionic or covalent bond. A chemical bond formed by the complete transfer of electrons from one atom to another is called ionic bond. Such compounds are called ionic compounds. A metal loses electrons to form cation and a nonmetal gains electron to form anion. It means an ionic bond is formed between a metal and a nonmetal. Formation of ionic bond can further be understood by taking more examples. So, we will see the examples in the slides which are going to come up. So, let us revise the ionic compound. The formation of sodium chloride, that is NaCl. Sodium atom loses its valence electron to become a noble gas electron arrangement. Chlorine atom gains electron from the sodium atom to become like a noble gas electron arrangement. Then the ions are held together by the attraction of opposite charges. So this makes the NaCl bonding as ionic bonding. Now children, look at this slide. The formation of NaCl bonding already we have discussed. Now let us see MgCl, that is magnesium chloride, formation of magnesium chloride. So it is also an important example. Now let us see to the electronic configuration of magnesium. So it is 2, 8, 2. So we have 2 electrons in the outermost orbit. So in order to achieve noble gas configuration, it is easier for magnesium to lose 2 electrons. Therefore, the electronic configuration becomes 2, 8 and thus it loses 2 electrons. At the same time, chlorine, when you look at chlorine, the electronic configuration of chlorine is 2, 8, 7. So since it is a non-metal, it is easier for chlorine to gain 1 electron and become noble gas configuration. So it receives 1 electron. So the electronic configuration becomes 2, 8, 8. So magnesium has 2 electrons in the outermost shell and we will take 2 chlorine atoms. So these 2 electrons combine with each chlorine and so it becomes stable and there is a formation of magnesium chloride ionic compound. Now let us discuss another important topic, the properties of ionic compounds. First, physical nature. Physical nature of ionic compounds are hard crystalline solids because of strong force of attraction between positive and negative ions. These compounds are generally brittle and break into pieces when pressure is applied. The second point, melting and boiling point. These compounds have high melting and boiling points as large amount of energy is required to break strong interionic attraction. Then solubility. These compounds are soluble in water, that means polar solvents, and insoluble in organic solvents, that is non-polar solvents like kerosene, benzene, ether, petrol, etc. As water is polar in nature, it helps in separation of oppositely charged ions from their ionic compounds. Then conduction of electricity. The conduction of electricity through a solution involves movement of charged particles. Ionic or electrovalent compounds are good conductors of electricity, but they conduct electricity either in molten form or in the aqueous solution. A solution of an ionic compound in water contain ions which move to the oppositely charged electrode when electricity is passed through it. In molten form, the electrostatic force of attraction between the oppositely charged ions and overcome due to heat. This is the reason due to which ions move freely and conduct electricity. They do not conduct electricity in solid form because movement of ions in the solid state is not possible due to their rigid structure. So let us see only the key points of what we have discussed. First point, they are formed by transfer of electrons and are made up of ions. They are crystalline solids. They have high melting and boiling points. They are soluble in water but insoluble in organic solvents like petrol, kerosene, benzene, etc. They conduct electricity in molten state or in solution. So this is a very important board question. So you have to learn it with full details. Now let us pass on to the next topic, occurrence of metals. The Earth's crust is the major source of metals. Seawater also contains soluble salts like sodium chloride, magnesium chloride, etc. The elements or compounds which occur naturally in the earth crust are known as minerals. Those minerals from which metals can be extracted profitably are called ores. So now you know the definition, very important. So see to the slide, most of the metals, because of their high reactivity, they occur in compounds in nature. What are minerals? They are naturally occurring substances in which metals and their compounds are found in the earth's crust and are obtained through mining called minerals. Then what are ores? Minerals from which metals are extracted by a commercial profitable method are called ores. All ores are minerals, but all minerals are not ores. So this is a very important statement. Now here in the picture you can see some of the ores of the metals. Bauxite, it is a ore of aluminum. Then like this you have for lead, then for iron, for copper, zinc, then cinnabar, which is nothing but mercury. So these are the ores which are obtained in nature for different metals. This slide gives you the important definition of some terms which we commonly use in the extraction of metals. Metallurgy, the process of extraction of metals from its minerals or ore, is called metallurgy. It involves mainly three steps: concentration of ore, isolation of metal from concentrated ore, purification of the metal. Then ganj, ores that are mined out from the earth contains large amount of impurities including soil, sand, etc. These are known as ganj. On the basis of the reactivity of metals are extracted in three different ways: extraction of metals with low reactivity series, extraction of metals with medium reactivity, extraction of metals with high reactivity. So children, you can take any definition which is known for you or which is easy for you. Now here I have given you again the definition of minerals and ores. Minerals, the elements or compounds which occur naturally in the earth's crust are called minerals. Ores, minerals that contain very high percentage of particular metal and the metal can be profitably extracted from it. Such minerals are called ores. Now let us pass on to the next heading, that is extraction of metals. What do you mean by extraction of metals? The process of obtaining pure metal from its ore is called extraction of metals. Some metals are found in Earth's crust in free state, while some are found in the form of their compounds. The metal present at the bottom of the reactivity series are least reactive, so they are found in free state. Example, gold, silver, platinum, copper, etc. The metals at the top of the reactivity series, for example, sodium, potassium, calcium, magnesium, aluminum. They are highly reactive, so they are not found in nature as free elements. The metals in the middle of the reactivity series, such as zinc, iron, lead, etc., are moderately reactive and they are found as oxides, sulfides, or carbonates in the Earth's crust. Ores of many metals are oxides, as oxygen is very reactive to elements and is easily abundant on the Earth's surface. Thus, the different techniques are used for extraction of metals depends upon their position in the activity series, which is divided into three categories: metals of low reactivity, metals of medium reactivity, and metals of high reactivity. Summary of several steps involved in the extraction of pure metals from their ores is given in the following slides in the form of flow chart, and you can understand it well as we take each and every case of this. Yes, children, look into this slide. This slide gives you the flow chart of the process involved in the extraction of the metals from its ore. The ores can be divided into three. It can be metals of high reactivity or metals of medium reactivity and metals of low reactivity. So this you can infer it from the reactivity series. So metals which are on the top, they are called as metals of high reactivity. Metals which are in the middle, they are known as metals of medium reactivity. Then the metals which you find at the bottom of the reactivity series, they are regarded as metals of low reactivity series. Now let us first take metals of high reactivity. So metals of high reactivity, they are electrolysis of molten ore. So what we do is, from the molten ore is electrolyzed. From that we get pure metal. Now let us take the last one, metals of low reactivity series. So here also electrolysis of the molten ore is done and from which pure metal is obtained. After obtaining the pure metal, electrolysis of molten ore is again formed and then it is refined. So we get pure metal. And now let us see to the ores of metals which are in the middle of the reactivity series. Now they are divided into two, the ores which contain carbon and the ores which contain sulfur. So carbonate ores and sulfide ores. Now by a process called calcination, carbonate ores are converted into oxide ores of the metal. And by the process of roasting, sulfide ores are converted into oxides of the metals. Then after becoming the oxides of the respective metals, they are reduced to metals and then refined. So these process we will see one by one in the next slides. Children, now let us see the extraction of metals which are of low reactivity, that is which occur in the bottom of the reactivity series. These metals, being less reactive, can be obtained by reducing their oxides to metals by heating alone. Let us take first the case of cinnabar. The chemical formula for cinnabar is Hgs, mercuric sulfide. It is an ore of mercury. When heated in air, it first changes into its oxide. that is HgO, mercuric oxide, and then reduced into mercury metal on further heating. The equations involved here are very, very important. So, cinnabar 2HgS with 3O2 gives 2HgO plus 2SO2. So, the cinnabar, which is mercuric sulfide, is converted into mercuric oxide by the process of heating first. Then further heating HgO, that is mercuric oxide, now it is separated as mercury and oxygen. So the equation is 2HgO gives on heating 2Hg plus O2. So this is how mercury is being separated from its ore. In the same way, we can see for copper glands. Copper glands Cu2S, cupric sulfide. When it is heated in air, partially oxidized and oxidized product react with the remaining copper glands to give copper metal. So look at the equations. 2Cu2S plus 3O2 gives 2Cu2O plus 2SO2. On further heating of Cu2O with Cu2S, then it gets separated as 6Cu plus SO2. So the equations are very important in the case of this. Therefore, children, be thorough with both the cases. Many times the extraction of metals at the bottom of the reactivity series, it is being asked frequently. Children, let us pass on to the extraction of metals present at the middle of the activity series of medium reactivity. The metals in the middle of the activity series, such as iron, zinc, lead, copper, etc., are moderately reactive. These metals are usually present as sulfides or carbonates in nature. These sulfides or carbonates are first converted into oxides because it is easy to extract metals from its oxide ores than its sulfide or carbonate ores. Sulfides are converted into oxide by roasting, and carbonates are converted into oxide by calcination. The metal oxides thus obtained are then reduced to the corresponding metals by reduction using suitable reducing agents such as carbon. Chemical reactions involved in the roasting and calcination are like this. First, let us take roasting. It is the process in which sulfide ores are heated below its melting point in the presence of excess air to convert it into metal oxides. So the definition is very important. So roasting, the definition is, it is the process in which sulfide ores are heated below its melting point in the presence of excess air to convert it into metal oxides. So 2ZnS plus 3O2 gives on roasting 2ZnO plus 2SO2. So zinc sulfide is converted into zinc oxide by the process of roasting. Now let us see calcination. Calcination is the process in which carbonate ores is heated below its melting point in the absence of air to convert it into metal oxide. Example, zinc carbonate ZnCO3, when heated, it decomposes to give ZnO plus CO2. So the zinc carbonate ore is converted into zinc oxide ore, and since it is a carbonate of impurity, this process of converting carbonate into oxide ore it is called as calcination. Now let us see the reduction of the oxides. So the reduction of oxide ores, it is the process of conversion of metal oxide ore into metals. It can be done by heating the oxides with suitable reducing agent like carbon in the form of coke. So ZnO plus carbon C gives Zn plus CO. Sometimes displacement reaction can also be used to reduce metal oxides to metals. The highly reactive metals such as sodium, calcium, aluminum, etc. are used as reducing agents because they can displace metals of lower reactivity from their compounds. Example, reduction of manganese dioxide with aluminum powder. So, in this way, the metals ores are converted from first. Children, let us pass on to the extraction of metals present at the middle of the activity series of medium reactivity. The metals in the middle of the activity series such as iron, zinc, lead, copper, etc. are moderately reactive. These metals are usually present as sulfides or carbonates in nature. These sulfides or carbonates are first converted into oxides because it is easy to extract metals from its oxide ores than its sulfide or carbonate ores. Sulfides are converted into oxide by roasting, and carbonates are converted into oxide by calcination. The metal oxides thus obtained are then reduced to the corresponding metals by reduction using suitable reducing agents such as carbon. Chemical reactions involved in the roasting and calcination are like this. First, let us take roasting. It is the process in which sulfide ores are heated below its melting point in the presence of excess air to convert it into metal oxides. So the definition is very important. So roasting, the definition is, it is the process in which sulfide ores are heated below its melting point in the presence of excess air to convert it into metal oxides. So 2ZnS plus 3O2 gives on roasting 2ZnO plus 2SO2. So zinc sulfide is converted into zinc oxide by the process of roasting. Now let us see calcination. Calcination is the process in which carbonate ores is heated below its melting point in the absence of air to convert it into metal oxide. Example, zinc carbonate ZnCO3, when heated, it decomposes to give ZnO plus CO2. So the zinc carbonate ore is converted into zinc oxide ore, and since it is a carbonate of impurity, this process of converting carbonate into oxide ore, it is called as calcination. Now let us see the reduction of the oxides. So the reduction of oxide ores, it is the process of conversion of metal oxide ore into metals. It can be done by heating the oxides with suitable reducing agent like carbon in the form of coke. So ZnO plus carbon C gives Zn plus CO. Now let us see the highlights of the difference between the two processes, roasting and calcination. So roasting, ore is heated in excess of air. In calcination, ore is heated in the absence or limited supply of air. Roasting is used for sulfide ores. Calcination is used for carbonate ores. Sulfur dioxide is produced along with metal oxide. Carbon dioxide is produced along with metal oxide. So the equations will be the next point of difference. So this question is basically the difference between roasting and calcination. Children, let us now go to extraction of metals at the top of the activity series or of high reactivity series. The metallic compounds at the top of the reactivity series cannot be reduced by carbon or any other reducing agent due to their high affinity with oxygen. Therefore, electrolytic reduction is employed for metals like sodium, magnesium, calcium, etc. Electrolytic reduction. What is this electrolytic reduction? The salts of these metals like chlorides in molten form are electrolyzed. Metal is deposited at the cathode, the negative electrode, and chlorine is liberated at the anode, the positive electrode. The reactions are as follows. At the cathode, sodium plus ion plus the electron. So it gives the neutral sodium with reduction. At the anode, two chlorine ions gives chlorine neutral ion with the combination of two more addition of electrons. Similarly, aluminum is obtained by the electrolytic reduction of molten aluminum oxide and it is called as alumina. Now let us pass on to the next topic, refining of metals. What do you mean by refining of metals? It is the process of purification of metals obtained after reduction. Various methods for refining are employed, but the most common one is electrolytic refining. So the electrolytic refining is explained in this slide. Many metals like copper, zinc, nickel, silver, gold are refined by this process called electrolytic refining. What is the process involved in this? In this process, a thick block of impure metal is used as anode and a thin strip of pure metal is used as a cathode. A solution of the metal salt to be refined is used as an electrolyte. When electric current is passed, the metal ion form the electrolyte are reduced as metals which gets deposited on the cathode. An equal amount of pure metal from the anode gets oxidized to metal ion and goes into the electrolyte and form from these goes to cathode and get deposited. This cycle is repeated until whole of the metal ion from the impure block is divided into and deposited on the cathode. The soluble impurities go into the solutions, whereas the insoluble impurities settle down below anode and are known as anode mud. Example, in the electrolytic refining of crude copper, here anode is impure copper, whereas cathode is strip of pure copper. The electrolyte is a solution of acidified copper sulfate. On passing electric current, the pure copper is deposited on the cathode. Children, by this we come to the end of today's class. Today we have discussed about various subtopics. First, we have discussed about the reactivity series, what a reactivity series is, and how are the metals arranged in that series, and how to remember the list of elements in the same order, a shortcut for that. So learn it very carefully and remember the sentence. Then we have applied in metallurgy, extraction of metals at the top, middle and lower reactivity series. Then finally we concluded with electrolytic refining, that is purification of metals. Right, children? So go through the textbook as I told you earlier, and those important topics or the concepts get underlined so that it becomes easy for you when you revise for your examination. So we will say goodbye to you from this morning and have a lovely day.